All right, in this video, I'm going to talk about how to name a vector and how to find its component form. Feel free to pause the video at any time if you'd like to write any of the information down before listening to me explain it. So vectors, this purple thing right here is a vector. So what vectors are is they're just an ordered pair of real numbers that represent a directed distance. So what that means essentially is that it is something that has both size and it has a direction. So it's very similar to a ray from geometry in the fact that it starts at a specific point, in this case A, and then it goes towards another point. So you see this arrow at the end here. However, a ray doesn't have a length. It goes on forever in the direction of its arrow, where a vector stops at a specific spot. So it has the arrow to show you where it's starting and where it's ending, but it doesn't go on forever. So that length, what you're going to find out later is that's called magnitude. So it has both magnitude and it has a direction. So it's got an initial point, in this case A, it's got a terminal point, in this case B. There's what's called components to the vector. So it has a horizontal component, kind of like the run, or basically exactly like the run in slope, and then a vertical component like the rise. So over on this picture over here, so here's your horizontal component. So again, the purple part is the actual vector. So it has a horizontal length called the horizontal component, and it has a vertical length called the vertical component. And we're going to figure out how to find these in a little bit here. Then vectors can be found all over the coordinate plane. This one specifically is written in standard position. Standard position means that the initial point, or the point without an arrow on it, is at the origin or starting at the origin, then it goes towards some other point. So any vector that has its initial point at the origin is considered in standard form. Then we can write vectors. So now you're not going to write a vector with a soft bracket or like an ordered pair bracket. You have these pointy brackets. You're going to write in this. So when you see these pointy brackets, that means it's the components of the vector. So the horizontal component, again, is that horizontal length. It's the x distance of that vector. So in this case, for this one, since we're starting at 0 for the x and we're going to 4, the horizontal component, if you were to literally count that, would be 4 units. And since it's going to the right, that's a positive movement. So then the vertical component, okay, would be how long this blue line is here, and this one is going up, so that's going to be a positive as well. So this one is going from a 0y coordinate to a 3y coordinate. So if we were to be able to count that, that would just be 3. So when it's in standard position, it's really nice because this terminal point gives you the components as well. So then the terminal point and the component form are exactly the same if it's written in standard form. A few other things about vectors. So you write it again with the initial point first. So the one without an arrow. So when we're looking at this diagram, this purple vector, we would call it vector AB. So name it starting, initial, ending, terminal, just like a ray from geometry. Then above it, we draw a picture of a vector, however, only a half arrow. So you'll see that it only has that half arrow above it. That's for vector. So vector AB. Another way that you can name a vector from a diagram is if you see a bold lowercase letter. So in this case, this one could also be called vector V. Oops, let me change the color to match. Oops. So this one could also be labeled vector B. All right, let's go ahead and look at a few examples on here. I guess I didn't put any letters on here. Let me do that quick. So we'll put A, B, C, D, All right, let's go ahead and name some of these now. So let's come up with the name of the red arrow, of the red vector, sorry. So again, when you're naming this, you want to start at the letter of the initial point and go towards the terminal. So this one's name, the red vector's name is vector AB. Draw a little half arrow above that. Let's go ahead and name all of these and then get into component form. Blue, okay, so the blue one's name starts with G and goes towards H. So GH would be the name for that one. Purple, initial point is F with no arrow next to it, going towards the arrow. So the arrow stops at point D. So vector FD. And then finally, vector EC here. So there are the names of each of those vectors. Then let's go ahead and do the component form. So when you're doing component form, you want to count from the initial point towards the terminal point. And you want to do the horizontal and then the vertical component. So for this red, we're going to do the horizontal, count that. So 1, 2, 3, 4. So the horizontal component is -4 since it's going to the left. Okay, so that horizontal component there is -4. Vertical component is up 2. So that's going to be a +2 for that component. So start again at the initial point, go towards the terminal point, do horizontal first, then vertical. So for this blue one, okay, we're going to do the horizontal component first. So count that 1, 2, 3, 4 to the right. So the horizontal component is a +4. Then do the vertical component. So that's going to be down. So this one is going to be a negative, and then count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is 4, -12 for the components of that blue vector. The green one, so again, start at E, the initial point, and then you're going to count the horizontal movement. Well, this one doesn't go either way, left or right. It's going straight up. So this one's horizontal component is 0. Okay, vertical component is going to be the same as the length of this vector. So just count 1, 2, 3, 4, 5, 6 units. And then it's going up, so that's a positive. Purple, start at F, horizontal, so count over and then up. So this one's going to have 2 positive components. So 1, 2, 3, 4, 5, 6 to the right, and then 1, 2, 3, 4 up. Now, it's super important to remember that when you're working with vectors, they have a length. So it's not, you're not actually counting slope on these. So you don't want to simplify anything. For instance, on this red vector, you don't want to count just to this first spot here. Whoops. Like if you were counting slope, again, it would be rise over run number 1. But you would only go into the middle here. So the slope of this line is -1/2. We don't want to simplify any of those because the direction and the actual length of the vector matters. So make sure you go all the way from the initial point to the terminal point when you're counting. Then if you're given a vector, so if you're given ordered pairs other than, so let's pick a couple of these over here. So if we were looking at this, let's actually look at one of the ordered pairs here. Let's do this purple one. So 1, 2, 3, 4, -4. 1, 2, 3, 4, 5, 6, 7. So if we had only known the ordered pairs here, so for D it's 2, -3. If this weren't graphed, so ours is graphed, so it's really easy to just draw on the horizontal and the vertical and just count them. Okay, but what if we were only given these ordered pairs? That's what we're going to look into on the next slide. So if you're only given the ordered pairs of the initial point and the terminal point, then you're going to use subtraction to figure out how far apart they are. This is called the tip to tail rule. Okay, so you want to do the head minus the tail, the head being the terminal point, okay? And then the tail being the initial point. So you want to start at the arrow or the terminal, okay, go to the initial. So you may want to write down for this terminal minus initial. Okay, so you want to start at the terminal, subtract the initial. So let me put some colors here. I'm gonna get rid of this actually. Okay, so let's go ahead and say the initial point, okay, is our red points, and then the terminal is our blue. So we're gonna take the terminal X value minus the initial X value. We're gonna take the terminal Y value minus the initial Y value to come up with our answers. So on this one example that we're gonna look at, so we've got the initial point here, which would be your X1, Y1, and we've got our terminal point here, which is our X2, Y2. So let's use this tip to tail rule here to do it, and then let's check it graphically. So we're gonna go ahead and subtract these. So we're gonna take our X2 minus our X1, okay? So X2 is 7 minus our X1, which is 1. Be careful if there's negatives in there. And then our Y2, which is 6, minus our Y1, which is 3. So all you're doing is figuring out how far apart these two numbers are, okay? And now it's going to matter the direction. So if you mix these up, if you start with the initial point, your numbers are going to be backwards, or they're going to be opposites of what they're supposed to be. You're going to get 5 instead of -5. So be really careful on that. So for this one, our component form is 7 minus 1, which is 6, and 6 minus 3, which is 3. So this should be our horizontal component, and this should be our vertical component. So let's go ahead and graph these 2 points and check to make sure. So first point is 1, 3. And then terminal point is 7, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, so there's our 2 points. So if we connect these with a vector, sorry. Okay, so if we connect those, then we should be able to count the horizontal component here, which is going to the right, which is positive, which is what we have. And then we should also be able to count the vertical component, which is going up, which is positive, which is what we have. So go ahead and just count those: 1, 2, 3, 4, 5, 6. And then the vertical, 1, 2, 3, which matches this. So we did that tip to tail method correctly. So tip to tail is just, you got to start with the arrow or the terminal point, subtract the initial. Make sure you do not get those backwards, or these will be opposite of what you wanted, and the vector won't be representing the right direction.